Hello, today in this video we are going to start with a new topic, the next topic of sequence and series, that is geometric progression. So we'll start with the geometric progression definition. So which sequence is called as GP, that is called as geometric progression. See here, so in the sequence of the die, say 2, 4, 8, 16 like this, or we can say anything, say 3, 3 with 9, 27 like this. This particular sequence are called as geometric progression. Why it is called geometric progression? If you divide this and this, that is 4 upon 2 in this first sequence, 4 upon 2 is always equal to 8 upon 4 is always equal to 16 upon 8. So in general, we can say that Tn plus 1 upon Tn, this all are equal and that is constant. That is, if the ratio of two successive terms is constant, then that particular sequence is called as geometric progression. So what is the definition of geometric progression? The geometric progression is what? Ratio between two successive terms in sequence is constant. The ratio between the two successive terms in the sequence is constant, and that sequence is called as geometric progression. That is, if T1, T2, T3, that is Tn plus 1 in geometric progression, then T2 upon T1 is equal to T3 upon T2 is equal to T4 upon T3 is equal to Tn plus 1 upon Tn. That is equal to what? Constant. Constant means it is a pair of n. So when this type of sequence is there, it is called as a geometric progression. That's very simple here. In this, so remember this is the definition of geometric progression. So next part, suppose geometric progression is given with the first term as A and R is a common ratio. Suppose A is first term and R is equal to common ratio. If A is the first term and R is a common ratio of any geometric progression, then the sequence becomes AR square, AR cube, like this. That means the first term T1 is A, T2 is what? T2 will be AR, T3 is AR square, T4 is what? AR cube. So if you observe this, we can say that the T1 is nothing but AR 1 minus 1. This is T2, T2 is AR 2 minus 1. T3 is nothing but AR 3 minus 1. So, in general, when it's come to Tn should be what? AR n minus 1. So that is the nth term in the geometric progression is always given by Tn is equal to AR n minus 1. So that is the formula where A is first term and R is a common ratio between the two terms. So that is the formula to find out the nth term or general term of the geometric progression. Similarly, Sn formula, so sum of the nth term in this is always given by the formula here, Sn, sum of G. N terms, in fact, it is the n terms of G here. So sum of n terms of geometric progression, so consider A plus AR plus AR square like this. Then I am multiplying this, say it is equal to S. It is equal to what? S is equal to this one. AR n minus 1. So this is the first equation. Multiply this with R. So multiplying this with R, so become RS, but I'm not writing here, I'm writing here, so that is AR plus AR square plus, like that, AR n minus 1, and one more term will come, that is AR raised to n, because you have to multiply R with each term, so A to R, so AR, I am writing that here, here multiply, so I am writing here, so that now we subtracting this two. If you subtract this two, what happens? S minus Is is equal to what? A will remain. This is cancel, and this will remain minus AR n, like this. So if I take A common in this, A is 1 minus R raised to n, S 1 minus R. So we can say that S is equals to, so this is the formula here. So Sn, sum of n term, S is equals to given by A into 1 minus R raised to n upon 1 minus R. Now the same, if we take a minus common out of both, we can say A and so this can be same. Both formulas are same, but we can take a minus common in the numerator, minus common in the denominator, we will get like this. Now, generally we use first formula, that is Sn, first formula, this one and this one, for two different conditions. This is there when the ratio is greater than 1, so that a negative value will not come. So here it's very simple. When the mod of the ratio is, the mod of R is greater than 1, we use this formula, R is to n minus 1 upon R minus 1. This is a formula to find out sum of n terms in geometric progression. Similarly, if A plus AR plus AR square is goes to infinity, infinite series, then S infinity is always infinity for R greater than 1. But if R is less than 1, if R is less than 1, R raised to n will tends to 0. R raised to n will tends to 0. So we put R raised to n in this, therefore S infinity become A upon 1 minus R. So that is a formula to find sum of infinite series in geometric progression. So here, so these are the formulas here, Tn, this is Sn to find, and this is S infinity. So that is an important formula which you have to note down. And then based on this, we will start few sums in the first. Yes, so now the actual sum, exercise 2.1, question number 2 can do. What is given here? A is given as 7 upon 243, R is equal to 3. What is P6? So P6 you have to calculate. We easily find Tn first if you want directly. Tn क्या होता है? Tn का formula है AR n minus 1 for the geometric progression. So here it is 7 upon 243. R का value दिया है this. So this is the formula for Tn. For T6, put n is equal to 6 in this, so it becomes 7 upon 243, 6 minus 1, like this. So that is 3 raised to 5. So T6 is equal to what? 7 upon 243 into 3 raised to 5. So that is 7 upon 243 into 243 is equal to 7. So what is that? T6 is equal to 7. So 6 term in the sequence will be what? 7. That's a very simple one. Similarly, the next question here, the similar questions are there, so we will not do that. Which term is a 5 raised to 10 here? The question number 2. Question 2, the third question here. The third question is, which term 5, 25, 125. So what is the 5 raised to 10, 5 raised to 10 term is 5 raised to 10 will be what is the which term? This clear is very easy one if you observe it. And this question 3 by observation. T1 is 5 is to 1. T2 is 5 is to 2. T3 is 5 is to 3 because it's 5, this is 25 and this is 125. Clearly observation. And therefore 5 is to 10 will be what? 10th term. So answer is very simple. 5 is to 10 will be 10th term. So that's very easy. There's nothing in this. There's nothing in this. Next, question number 5 is to prove that question. The question number 5 here. So what is question number 5? Of your textbook, question 5. Tn is given as 5 raised to Tn is 5 raised to n minus 3 upon 2 raised to n minus 3. This is Tn given. Show that first term and the common ratio. Show that it is GP and find first term and common ratio. So here Tn is given. So whenever there is a Tn given and you have to prove that it is GP, remember that you have to do its definition. So what's the definition of Tn? It is Tn plus 1 upon Tn should be always constant. Tn plus 1 upon Tn should be constant. So here we have to find Tn plus 1 and we have to find Tn is already given and then find the ratio of that 2, and if that ratio is constant means it should be free of n. There should not be n present. So that is the definition. So your solution Tn is already given to you, that is 5 raised to n minus 3. So Tn plus 1 will be what? 5 raised to n plus 1 minus 3. 2 raised to n plus 1 minus 3. So it is 5 raised to n minus 2 upon 2 raised to n minus 2. So now Tn plus 1 upon Tn. So what is this? Tn plus 1 upon Tn will be 5 raised to n minus 2 upon 2 raised to n minus 2 upon n minus 3. So like this. So which is nothing but n minus 2 into. So this here 5 raised to n minus 2 minus n plus 3 into 2 raised to n minus 3 minus n plus 2, that is goes up. So this n get cancelled, so it is 5 raised to plus 1. And here it is into 2 raised to minus 1. So it is clearly Tn plus 1 upon Tn will take 5 by 2, which is a constant. Therefore, given sequence is in geometric progression. That's true. And this is your common ratio also, because that is the ratio of the two consecutive terms, Tn plus 1 and Tn. And therefore, here, common ratio is R is equal to pi by 2. And for the first term, put n equal to 1 in Tn. So that is T1 is equal to 5, 1 minus 3 upon 1 minus 3. That is give you, it is 5 raised to minus 2 upon 2 raised to minus 2. So that will go up, so become 4, and this will come down, so this 4 upon 25. So first term is 4 upon 25. And common ratio is that's the answer. So here the first term will be 4 upon 25 and the common ratio is 5 by 2. That is the answer. So I think it's very easy. Everybody should understand this one. Next question is also similar to this. So not doing. So we know how to do the next part, that is with the, you have to find three terms given. Done this, आगे बढ़ें. Next question is question number 6. Find the three numbers in GP such that the sum is 21. Question number 6. Three numbers in G. Sum diya hai. What is the sum is given? The sum is given as 21 and the sum of their square is 189. Sum is 21 and sum of their squares is 189. Find numbers. So that's the question number 6. So find the three numbers in geometric progression such that the sum of the three numbers is 21 and sum of the squares is 189. So whenever there is a GP, we have to assume, so solution here, let A by R, A and AR are three numbers. These are the three numbers in geometric progression. If we assume that A by R, A and AR are the three numbers in geometric progression. So as per given rule, as per given condition, what is the condition given here? The sum of this AR is given as 21. If I take A this side, so A by R, AR is equal to 21. This dividing by A is 1 upon R plus R is equal to 21 minus this. That is the first equation. And next, another condition is given. What is another condition given here? Another condition is given. What is another condition is given? Sum of the squares. Sum of the squares is 189. So this A square is taken this side. A square upon R square is 189 minus A square divided by A square. So 1 upon R square plus R square, 189 minus A square upon A square is like this. So that is number 2. So now, after this, what is the value of R plus 1 upon R square? What is R plus 1 upon R square? We know that R plus 1 upon R square is equals to R square plus 1 upon R square plus 2. So put the values in this. Therefore, from 1 and 2, this value R plus 1 upon L is 21 minus A upon this, the whole square. R square plus 1 upon R square value is what? 189 minus A square upon A square. So here there is now only one variable, so we can solve this equation easily. Understood? Because we use this for this one. This is the standard formula, R square plus 1 upon R square, 2R, because A square plus B square plus 2AB formula we applied there. So by using that formula we get this one. So now what is this? 21 square, that is 124. 21 plus 12 is how much? 21 square is 441, sorry. This 441 minus 42A plus A square upon A square is equals to A square is multiplied by upon A square. So A square get cancelled. So it is 441 minus 42a plus a square 189, that is again a square. So again a square get cancelled. So it is 441 minus 189 is equal to 42a. So 441 minus 189, what is that? 441 minus 189 is 2. 12 minus 9 is 3. So it is 11 minus 9 is 2. 14 minus 9 is 5, I think. 14 minus 9 is 5. This is 252. 252 into 42. Yes, so it is 252 is equal to 42a. So a is equal to 6 because 6 2s are 12, 2 1, 6 4s are. So answer is a. It should be equal to what? 6. So the question here is you have to find first the term. So put that value in any one of the expression here. So from 1 we can say substitute a is equal to 6 in 1, that will give you that is 15 upon 6 r square 15 upon 6, that is nothing but 3 5s are 3 2s is 5 by 2, so it is 2r square plus 2 into this, like this. 2r square plus 2 is equal to 5r, so it is 2r square minus 5r plus 2, so 2 into 4, so it is 2r square minus 4r minus r. 2r common, r minus 2 minus 1 common, r minus 2 equal to 0. So it is 2r minus 1, r minus 2 is equal to 0. So r is equal to what? 1 upon 2, or r should be equal to 2. So these are the two possibilities, r equal to 1 by 2 or r is equal to 2. So the required terms are 6 upon 1 by 2, 6 into 1 by 2, that is 12, 6, 3, or 3, 6, 12, like this. So anyone, because anyone side, so now we can function the sum as 21 and the sum of the square 9, 36, 144, it is 189. So this is the correct answer for this. Understood? So it's very simple. It's very simple. Yes, the next question after that, there is question number say 8 or 9. The fifth term of GP is x is given as question 9. T5 is equal to x. The fifth term of GP is x. Eighth term of GP is y. T8 is y. Eighth term of the GP is y. And 11th term of GP, that is T11 is z. The question is verify that y square is equal to, verify that y square is equal to xz. This you have to verify. That's the question, yeah? You have to verify that y square is equal to xz. So let is first term and r is common ratio. Let a is the first term and r is the common ratio for this. So what is the T5 then? Solution here. What is T5? T5 will be a r raised to 4. So that is the T5. What is T8? T8 would be AR raised to 7. What is TI11 is AR raised to 10, which is given as X, Y, and Z. Now we want to verify this. So now LHS for this is Y square. So Y square is AR 7 plus square. So it is A square R raised to 14. And the right hand side is X into Z. So X is AR raised to 4 and Z is AR raised to 10. So it's A square is R raised to 14. Clear from this. So from 1 to LHS is equal to RHS. Therefore, Y square equal to XZ, which is verified. Like this. So it's very easy one. So it's very easy in this one. So this is very easy to do. Similarly, there is one more question. Question number 10 in this. So question number 10 says, look at the question number 10. So in the question number 10, it is given that PQR is in GP, then you have to prove that P plus Q, Q plus R plus S is also in GP. It is given that PQR is in GP. Then prove that P plus Q, Q plus R and R plus R is in G. P plus Q, Q plus R and R plus N is also in GP. So what is exactly meaning to prove in GP? How to prove it in GP? GP means the ratio between the two terms is always constant. That is the geometric progression definition. So here, solution, let R be the capital. I am taking R capital because small is already there. Let capital R be the common ratio for this. Since P, Q, R is in GP, therefore P को P रखेंगे. Q can be written in P basis that R is written as and S can be written in this way. Because the difference, the ratio is constant. So PR square upon P is nothing but R. This upon this is nothing but R. So that is the definition of geometric progression. So by definition of GP, we can say that Q is PR, R is PR square, and S is PRQ. Now to prove that P plus Q, Q plus R and R plus in GP, we have to prove that this upon this Q plus R upon P plus Q is equal to R plus S upon Q plus R. So this we have to prove. And therefore we can start with this level side and then we can easily prove it. So LH is here. So LH is Q plus R upon P plus Q, which is equal to what? Q का value लेंगे अपन PR. So it is PR. R का value होगा PR square. P as it is. Q is again PR. So what is common in both? If you observe in both, if the PR is common, क्या बचेगा 1 plus R बचेगा. क्या बचेगा 1 plus R. नीचे का कॉमन है P, तो P is common, so क्या बचेगा 1 plus R. 1 plus R, P cancel, so क्या बचेगा? This is R, that is the left hand side. Similarly, we can say a right hand side. So right hand side में क्या है? R plus S, Q plus R. R the value, it is PR square, and the S is PR cubed. Q is PR, R is PR square. What is common in the numerator? It is PR square is common. बचेगा 1 plus R. नीचे क्या common है? PR. So क्या बचेगा 1 plus R, 1 plus R, 1 plus R cancel, PP1 cancel, तो बचेगा R. So clear cut from this, left hand side is equal to right hand side. Hence proved. Hence proved that is P plus Q, Q plus R, and R plus S are in geometric progression. So like this, it's very simple definition. So whatever we discussed now, till now, it is based on simple definition of geometric progressions. Now we will go to the sum based sum, and that is the sum of the geometric progression. Now here we will solve the question based on the sum in the geometric progression. So similar sum on this. So for exercise, second exercise, that is exercise 2.2, question number 1 here. The question number 1 is 3, 6, 12, 24 is given to you. First, 3, 6, 12, 24. What is Sn? So Sn क्या होगा? So here we are at the first term A is 3 and R is 2. So Sn is when R is greater than 1. R is greater than 1. The Sn formula is A R minus 1. R is 2 minus 1. R minus 1. So we have to use that simple formula 3 R the value 2. So it is 2 raised to n minus 1 upon 2 minus 1. So answer is 3 into 2 raised to n minus 1. So that is a formula for sum of n terms in this. So it's very easy. There is nothing in this. So this type of sum, you have to just concentrate on whether it is what is the value of r, and then which formula we have to. Yes. So the next sum is third sum. 0.7 plus 0.07 plus 0.007 like this. What is the sum of n terms? Sum of n terms क्या होगा? So again, it is clear cut from this. So A is 0.7. What is the common ratio? If you divide this, it's 0.1. So R is 0.1 here, which is 0.1. It's less than 1. So here the sum of n term is given by Sn is equals to A 1 minus R raised to n 1 minus R. So we will use this formula in this. So A का value is 0.7 as it is 1 minus 0.1 raised to n. 0.1 raised to n upon 1 minus 0.1. So it is like this. So what is 1 minus this? It is 1 minus 0.1 is nothing but 0.9. So it is 0.9. So 0.7 upon 0.9. 1 minus 0.1 raised to n. Now 0.1 can be written as 1 upon 10. So you can keep the answer like this, 7 upon 9, 1 minus 0.1 raised to n. So, or we can write 0.1 is 1 upon 10 like this. So that is also okay. So this is the answer for this sum. Yes, the next question number 2 is A is given as 2, R is given as minus 2 by 3. And then what is the sum of first 6 terms in geometric progression? So we use the formula S of n. And here we look at the mod of R, which is 2 by 3 less than 1. So we will use that formula. So Sn is A 1 minus. So according to that, here A is 2, 1 minus R का value क्या है? Minus 2 by 3 raised to n. 1 minus 2 by 3. So minus become plus. So answer is 2 into, this is, we keep as it is 1 minus 2 by 3 raised to n. Here it is 3 plus 2, that becomes 5 by 3. This will go up, so it is 6 upon 5. It is 6 upon 5 with bracket 1 minus 2 by 3 raised to n. So like this, that is the sum of n terms. Now the question is, what is sum of 6 terms? So put n is equal to 6 in this, therefore it is 6 by 5, 1 minus 2 by 3 raised to 6. So what should be the answers? 2 by 3, you have to multiply 6 times. So it is 6 upon 5, 1 minus 2 into 2, 6 times, that becomes 64. This is 64, and this is 3 into 3, 9. 729. See what is the calculation of this? It's very simple. You just calculate 729 minus 64. So 6 upon 5, 729 minus 64 upon 729 like this. And then see what is the correct answer for this. So for important one, you just find the value as in the n and then put the whatever the required value of n as given question. So that's it. That's the easy one to this. Yes. The next concept is very simple here. How to find the sum of this 9 plus 99 plus 999 in terms. So n terms are there. So in this n terms, how to find sum of n terms is this 9 plus 99 plus 999 like this. So how to find n terms, sum of n terms? So it's very easy. The 9 can be written as 10 minus 1. This can be written as 100 minus 1. This can be written as 1000 minus 1. So now this 10, 100 and 1000. If you just observe this 10, 100, 1000. These are in geometric progression. 10, 100, 1000s are in geometric progression. So we take that in the geometric progression. So that in one bracket 10, 100, 1000 in one bracket like this, and 1, 1, 1 how many times? 1 plus 1 plus 1 is the n times. So n times here. This is n terms. So clearly here the common ratio is 10. First term is also 10. The sum of this is equals to what? 10 into 10 raised to n minus 1, 10 minus 1. And here it is n times, so it is n. So it is 10 upon 9, it is 10 upon 9, 10 raised to n minus 1, like this. So that's the answer. We can just, if you want, take a common LCM, so we can say it is 10 into 10 raised to n minus 1 minus 9n upon 9. So that's the answer for this type of question. So when this type of question 9999 is there, we have to solve like this. Or any other number, say 555, you make it in these forms. How? See one question based on the textbook. So the textbook question here. So it is given in the text. See in the text question what is given to point. It is question number 5, first one. Question number 5, Capella. 3 plus 33 plus 333. You have to find the sum of n terms. So what to do in that? The question is very simple. So we will take a 3 common in this. If you take a 3 common in this, what will be this? 1, 11, 1, 1, 1 like this, n terms will be there. 3 is taken as common. Divide by 9, multiply by 9. So this becomes 3 upon 9, 9, 99, 999 like this, n terms. So now this value is nothing but this one. That is, so I can put this as 3 upon n. 10 9, so that becomes 3 upon 81 is 3 upon 81 in the bracket 10 into 10 plus to n minus 1 minus 9n like this. So that is because of 333. When 333 is there, suppose it's 555, what happened to this? It becomes 5 upon 81. 666 becomes 6 upon 81. But this bracket remains as it is. So remember, this is very easy concept in this. But you should know how to do that. That's it. We should know the technique of this. If you know the technique of this, then that becomes very easy one. Yes, so next question, before going to the next question is similar to that. Suppose 0.1, 0.11, 0.111, you have to find the sum of n terms. What to do in this case? In this case, again the same, we'll move with the same concept here. That is, we make it 0.9, 0.9, so 0.9, you have to divide by 9, multiply by 9. Become 0.9, 0.99, plus 0.999. So like this. So now this become 1 upon 9. This is 1 minus 0.1. This is 1 minus 0.01. This become 1 minus 0.01. And like this, there is an end brackets. So end brackets, so if you just look at that, the first 1, 1, 1, n times, and the second bracket 0.1, 0.01, 0.001 n times here. The n terms we can say. So like this. Now this is clear cut. 1 upon 9. 1, 1, 1 n time will give you n, but here it is a GP. So GP, so with the 0.1 has a common ratio. The 0.1, 1 minus 0.1 raised to n upon 1 minus 0.1. So that is 1. That is our formula. So using this formula, so it is 1 upon 9 n minus 0.1. 1 minus 0.1 raised to n upon this is point. So that's the answer. We can write this as 1 upon n. N minus this is 1 upon 9. So this is we can say the answer in this. So again the same, suppose instead of this is 0.4. If it is 0.4, 0.4, so similarly this become what? It become 4 upon 9, n minus 1 upon n, 1 minus 0.1 raised to n. So this is the answer for this. So this 1 is replaced by 4. Suppose 0.5 will become 5 by 9 and so on. But the method is important. We can simplify this also. If you want, we can simplify this. 0.9 is you can 1 upon n, you can multiply it is n upon 9, 1 upon 81. So see what is given at the backside answer but in your textbook. But this is the simplified form of this. So this type of question we can solve like this. There is one more type in this. Now based on the concept we discussed, that is of geometric progression, we will solve few MCQs, that is JW level based on geometric progression. So we start with MCQs. Yes, so the first question in this JW level, x, 2x plus 2, 3x plus 3 in geometric progression, then what is the fourth term? The question is, what is the fourth term of the sequence? So now here first we find out x. So by definition, we can say that 2x plus 2 upon x should be equal to 3x plus 3 upon 2x plus 2, like this. So now there is 3 common in this. It is 3 into x plus 1. Here 2 common. X plus 1 get cancelled. So it is 3 by 2. 2x plus 2 upon x is equal to 3 by 2. Now this 2 will multiply here. That will give you 4x plus 4 is equal to 3x. So that gives you x is equals to minus 4. So x is equals to minus 4. The first term is that. The second term is 2x plus 2 ka value aega 2 into minus 4 plus 2. That is minus 6. 3x plus 3. So 3x plus 3, that is 3 into minus 4 plus 3. So it is a minus 12 plus 3. So that is minus 9. And then common ratio here, r is equals to 6 upon minus 4, that is plus 3 upon 2. So that means P4, the P4 will be AR cubed. So here A, the first term is minus 4 and 3 by 2 का cube. So that is minus 4 into 27 upon 8. So that is minus 27 upon 2. So the answer is minus 13.5. So this is the answer for the first question. Answer is minus 13.5. Yes, so next question, question number 20 is given that ABCD in geometric progression. So again by definition, just go by definition here. So by definition, one can say B upon A is equals to C upon B is equals to D upon C. Now, what is required in the option, according to that we have to move. So if you look at that option, according to the option, so what is the option given? If we add AC, if we add this, in this and this, you can say BA is equal to CB, that give you B square is equal to AC. If we add this and this, CB equal to DC will give you C square equal to AD. If we add this and this, BA is equal to DC, that gives you BC is equal to AD. And I think that is there in the option. BC should be equal to AD, which is there in option 4. So correct answer is BC is equal to AD. This all relations are correct, but out of which this is there in the option number 4. Yes, so here the next question, question number 21. So 21 is given that n plus nth term of geometric progression is 9, n minus nth term of GP is 4. Then what is Tn? So what is Tn? That's the question here. So by definition, what we can say Tn plus n is AR n plus n minus 1, that is given as 9. Tm minus n is AR n minus, this is equal to 4, and Tm is equal to AR n minus 1. So we don't know what is the value of this. So multiplying this to equation 1 multiplied by equation 2 will give you AR n plus n minus 1 into AR n minus n minus 1 is equal to 36. Now here A into A, that gives you A square. R n plus n is 2n, n cancel, that is minus 2 is equals to 36. So that is nothing but AR n minus 1, the whole square is 36. Let me square root on both the sides. AR n minus 1 is plus or minus 6. It can be plus or minus 6, and that is nothing but D n, that is plus or minus 6 here. So answer should be Tn is equal to plus or minus 6. Yes, next question, question number 22. The question number 22 here is this. Root 3 plus 1 upon root 3 plus 1 upon 3 root 3 infinite series is this. What is the sum of this infinite series? That's the question. So here R is equal to 1 upon root 3 upon root 3. So that gives you what? 1 upon 3. So this common ratio here is 1 upon 3. So by the formula S infinity is A upon 1 minus R. That is root 3 upon 1 minus 1 upon 3. And that gives you 3 minus 1 is 2 by 3. It is 2 upon 3. So that is 3 root 3 upon 2. So answer for the sum of infinite series is 3 root 3 upon 2. That's it. Yes, so the next question, question number 23, what is mentioned there? The first term of GP is 1 and the next term is the sum of the successive terms. That is very simple. There is a half. The half of that means the required GP become what? 1. Then next will be half of this. Next will be half of this. Next will be what? Half of this. Next will be what? Half of this, and so on. Because that is the meaning of this question here. Therefore, first, second, third, fourth. So T4 here, the answer is T4 is equal to what? 1 upon 8. That's the answer. Yes, so next question number 24. So 24th question here is, they are given in the fifth term is 2, and then what is the product of first 9 terms of geometric progression? So here, clear-cut, we know that T1 is A and that is A, and common ratio is R, we assume. So T1 is A, so T2 is what? AR, therefore T5 is AR raised to 4. So now this is given as 2. T5 is given as 2. Then product of 9 terms. So product of the 9 terms is AR square, AR cube, AR raised to 4, AR raised to 5, AR raised to 6, AR raised to 7, AR raised to 8. Like this, these are the total 9 terms starting from this 1, 2, like this. So clearly from this 1, A will be multiplied by 9 times, so it is A raised to 9 will come. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9. So A raised to 9. The R power will be added here. So it is 1 plus 2 plus 3 plus 8. Like this. Therefore, it is A raised to 9. R power will be what? 8 into 9 divided by 2. That is n plus 1. That is sum of n natural number is always given by n plus 1 upon 2. Using this formula, we get 8 into 9 divided by 2, and that is nothing but is cancelled with this. So it is A raised to 9, R raised to 36. If you take that A raised to 9, R raised to 36, so it is A R raised to 4 raised to 9, which is nothing but from this, so which is nothing but 2 raised to 9. So answer is 512, because 2 raised to 10 is everybody is known to you. 1 to 2, 4, so 2 raised to 9 is 512. So answer is 512. Yes, so next question number 25, it is infinite series, the value 5 that we calculate, x is to 1 by 3 into x is to 1 by 9. So it is the infinite series, and that clearly gave 1 by 3 plus 1 by 9, 1 by 27 up to infinite. So sum of infinite series is, here the common ratio is 1 by 3. The common ratio is 1 upon 3. So the sum of infinite series formula A upon 1 minus R. R is here 1 by 3. So that is x raised to 1 by 3 upon 2 by 3. So 3 cancels. So it is x raised to 1 upon 2, which is nothing but root x. So therefore y should be equal to root x. That's the answer. Question number 25. So y is equal to what? Root x. Yes, so one small concept here, that is number of GMs. N number of GM you have to insert between the two numbers A and B. Geometric number progression, remember that. So consider the first is A, then the next is G1, G2, like this Gn, and then B. Clearly from this, the G1 value will be what? AR. G2 value will be what? AR square. Gn value will be what? AR raised to n. So what is the value of B? B will be ARn plus 1. So that is exactly what we want. So here, when n number of GNs are inserted between A and B, with R as a common ratio, then the value of B will become B is equal to ARn plus 1. Therefore, B upon A is Rn plus 1. the common ratio becomes B upon A like this. So that is a very simple concept. So based on this concept, if you solve the question number 26, in question number 26, it is exactly the same mentioned there. What is there in the question 26? Question number 26 is mentioned that if n number is ratio, so what is common ratio? The common ratio is B upon A raised to 1 upon n plus 1. That is exactly the answer for this. That is a question number 26 is valid. Yes, so here the next question, question number 27. 5 GMs are introduced between 486 and 2 by 3. Then what is G4? So here again, first we want the common ratio. So common ratio is given by B upon this 1 upon n plus 1. So here B value is 2 by 3. This is 486. And n is 5. So it will be 1 upon 6. That is 5 plus 1. Like this. So 3 come down. So what is that? Well, 2 cancel with this first. So 2 2's are this 243, which is 3 raised to 5, and this 3. So it is 1 upon 3 raised to 6, 1 upon 6. So clearly it is 1 upon 3. So common ratio here is R is equal to 1 upon 3. And then G4 is A is to 4. So A is 486. 1 upon 3 is to 4, which is 486 upon 81. 3 into 3 into 3, 4 times is 81. So 81 6 are. So 4 G4 is equal to 4 8 G4 will be 6. So answer is the fourth geometric mean will be 6. That's it. Yes, so next question, question number 28. What is that? The question 28 is what is the product of n GNs between A and B? So here A, G1, G2, like this Gn and B. So common ratio is B upon A, 1 upon n plus 1. That's a common ratio. And G1 is G1 into G2 up to Gn will be what? AR into AR square up to AR raised to n, which is nothing but A raised to n into R raised to 1 plus 2 plus 3 up to n. So that is clearly it will be A raised to n, R raised to n into n plus 1 upon 2. Now what is the value of R? So what is the value of R here is, the value of R is B upon A, 1 upon n plus 1. And this again into n plus 1 upon 2. So this n plus 1 will get cancelled, and that is A raised to n, B raised to n by 2, A raised to n by 2. Now this n and this n by 2 also will get cancelled. So this A raised to n by 2, B raised to n by 2, which is nothing but we can say AB raised to n by 2, which can be written as root of this. That is the same way. So we can say that's the answer, AB raised to n by 2, or this in this way, that is square root of AB with n root of that. Yes, so here this is given 3 square, 3 cube like up to 3n. Then what is the geometric mean for this? So geometric mean is exactly the same as the mean of the first and last. That is the same, and so it is whatever the geometric mean when you discuss. We have to discuss first and last geometric mean, or second and second large geometric mean, third and third large geometric mean is always same when this is given in the sequence. So here it is. Answer will be what? 3 into 3n in the square root. So that is nothing but 3n plus 1 upon 2. So answer is 3 raised to n plus 1 upon 2 is the answer. So geometric mean Gn will be 3 raised to n plus 1 upon 2. That's it. Yes, so question number 30 here in geometric progression. For an infinite GP, the sum is 20 and the sum of that square is 100. The sum of the square is 100. The sum in GP is A plus AR plus AR square like this. AR n minus 1 is 20. Which is nothing, sorry, it is infinity series, so infinite is 20. So it is A 1 minus R is 20. Squaring both, we can say 1 minus R square is 400. So that is number 1. For A square plus A square R square plus A square R raised to 4. In this case, the infinite series, the sum is equal to 100. Now here, the first term is A square, the common ratio is R square, so it is 1 minus R square and that is equal to 100. So like this, so from this, so A square 1 minus R square is equal to 400, dividing this to, so dividing 1 by 2, 1 divided by 2, A square S square get cancelled. So it is 1 upon, you see this simply come, A square 1 minus R square, R the whole square, into 1 minus R square upon A square is equals to 4. So A square and this A square will get cancelled. Now here it is 1 minus R, 1 plus R, 1 minus R square is equal to 4. So this 1 minus R will get out. So this will multiply here and become 4 minus 4R. So this is 5R is equal to 3. So R is equal to 3 upon 5. So common ratio R for this is 3 upon 5. That is the answer. So the common ratio is 3 by 5. Yes, so question number 31. G is the geometric mean between x and y. Then what is the value of 1 upon g square minus x square plus, it is not minus, it is plus 1 upon g square minus y square. So now, since g is geometric mean between x and y, therefore g should be equal to root of xy. Therefore, g square is equal to xy. Now we will solve this, that is 1 upon g square minus x square plus 1 upon g square minus y square. So what is the value of g? Now put the value of g here. So value of g is x square minus y square, sorry x square plus 1 upon xy minus y square. So clear cut, what is the common here is x is taken common, y minus x plus, here y is taken common, x minus y. So just take an LCM here. If you want to take an LCM, the LCM is the same thing as x into y, y minus x. X into y, y minus x. So here you have to multiply with y. Here this is x minus y. So you make it y minus x. So minus taken common and then multiply with x. So this y minus x and this y minus x will get cancelled. So it is a 1 upon xy, which is 1 upon g squared. So answer for this question is 1 upon g squared. That is the answer for this. 1 upon. Here the question number 32, divide 150 into 3 parts so that the number will be in geometric progression, and the first number is less than third number by 120. So 120, directly go by option. So clear cut by option The sum of this should be 155 and T3 minus T1 is 120. Only one possibility. That is 5, 25 and 125. So, and this is satisfies, difference is 120 and this is in geometric progression as well. So answer is 5, 25 and 125 is the answer. So the next question, question number 33, what is the fraction value of this? 0.125, 125, 125 till infinite series. With the infinite series, so we can say that it is nothing but 0.125 plus 0.00125 plus 0.00060, then 125, like this is infinite base. So that can be equal as 125 into 10 raised to minus 3, 125 into 10 raised to minus 6, plus 125 into 10 raised to minus 9, and so on. So which is nothing but it is a GP. So GP is infinite. So here the first term is this. So therefore the sum is A upon 1 minus R. So A is 125 into 10 raised to minus 3. And what is the common ratio? Common ratio is 10 raised to minus 6 upon 10 raised to minus 3, which is equal to 10 raised to minus 3. So it is 1 minus 10 raised to minus 3. So that is nothing but 0.125 upon 1 minus 0.001. So it is 0.125 upon 0.999. So answer will be 125 upon 999. That's the final and the correct answer for it. So answer is 125 upon 999. Here, the next question, question number 34, which is a similar question but slight difference in that, because the recurring digit here is not all 3 but only the last 2 is recurring, that is 23. In the previous case, it is all 3 are recurring. So what to do in this case? It is almost similar. It is 0.1 plus 0.023 plus 0.000, then 2, 3 and so on. So clear-cut form this 0.1 remain as it is. 0, 2, 3 is nothing but 23 into 10 raised to minus 3. It is 23 into 10 raised to minus 5. So what is the next term? 23 into 10 raised to minus 7 and so on, like this. So this 0.1 remain as it is. And this is an infinite series now. This series is infinite series. So using that series formula, so here 0.1 plus A upon 1 minus R will come. So that is 0.1. 0.1 is nothing but 1 upon 10, we can say. The 0.1 is can be written as 1 upon 10. So A is here, it's 23 into 10 raised to minus 3 and 1 minus. The ratio here is 10 minus 10 raised to minus 2. So 10 raised to minus 2. Now this is 1 upon 10 plus 23 means 0.023 and this is 1 minus 0.01. So it is nothing but 1 upon 10 plus 0.023 divided by 0.99. So we multiply with 1000 in the numerator, so it's 1 upon 10 plus 23 upon 990. So 990, take the LCM here, so it is a 99 upon 990 plus 23 upon 990, which gives you 23 and this 990 will give you 122 upon 990. So 122 upon 990 divided by 2 is divisible. it is a divisible. So it is 61 upon 495. It is 61 upon 495. So this is the answer for this one. Answer is 61 upon 495. I think everybody understood this one, right?